All right, time for another movie about alkenes, and today I'm just going to talk about alkene nomenclature. So let's start with this molecule. So this is cyclohexane. When we put an alkene in it, so we put a carbon-carbon double bond in it, it becomes cyclohexene. So essentially we just changed the ane to an ene. Like things like cyclohexanol, we do not have to put a number in there because it's a cyclic molecule, so we can just say, well, that's carbon 1, that's carbon 2. How about these two molecules? Well, they're isomers. They are both C6H8. They both have 3 degrees of unsaturation. They're a cyclohexane with 2 alkenes. So both of these are cyclohexadiene. But you can see they are not the same molecule. So in this case, the numbering of the carbons is very important. And we always want to start, in this case, the alkene is the most important functional group, so we have to start with the alkene on the 1 carbon. The other thing that we have to do is whatever carbon we pick for the 1 carbon, so say we pick that carbon as the 1 carbon, it's got an alkene on it. Well, the 2 carbon must be the carbon on the other side of the alkene. So this carbon is pi bonded to that carbon. So if this carbon is 1, this one must be 2, and then going around 3, 4, 5, 6. And so what we would call this is, say, this is 1, this is carbon 1, it's connected to carbon 2. We don't have to say 1 to 2. We just know that this starts at 1. This alkene starts at 3. So this molecule is 1, 3 cyclohexadiene. On the right, if we number it the same way, 1, 2, 3, 4, 5, 6. Again, we kept 1 and 2 are connected by an alkene. In this case, this is 1, 4 cyclohexadiene. Now let's do some straight chain molecules. What's this? Well, this is butene, but this is also butene. So in order to differentiate these, we have to give an address to the alkene, just like we do with the alcohol or the alkyl halide, what have you. So the ene is the most important functional group. It's the parent, so we number from left to right, as the molecule is shown here. This molecule is 1-butene. You don't have to say 1,2, because if 1 is an alkene, we know that it's directly connected to carbon 2. So this molecule is 1-butene. The molecule on the bottom, well, we can number it from left to right, or we can number it from right to left. It doesn't matter because it's symmetrical. And in this case, the alkene connects carbon 2 and carbon 3. So as before, we just have to pick the lower number, and we can call this 2-butene. Now, you may recall from the last video that 2-butene also has a diastereomer. Let's draw that out. Pause this if you would like and see if you can figure it out first. Here it is. We can number it in the same way, and we would name it the same thing, 2-butene. Since pi bonds don't rotate, these two molecules are diastereomers. In this case, the carbons, the methyl groups, are on the same side of the pi bond. In this case, they're on the opposite side of the pi bond. So one of them is cis and one of them is trans. So cis-2-butene, trans-2-butene. What about a bigger molecule? Here are some larger alkenes. All of them are isomers. All of them are hexenes. This one is 1-hexene. There's no cis or trans here because, the attached to this carbon are 2 hydrogens, which are the same. Here, one of these is cis and one of these is trans. So the way I've drawn it, this one here is cis. The big groups are on the same side of the double bond. This one is trans. The carbon chains are on opposite sides of the double bonds. So here we number from the left. This is trans 2-hexene. On this side, we number from the right because the alkene is closer to the right. And this is cis 2-hexene. Now, cis and trans really only work for alkenes that have hydrogens on each of the alkene carbons. So, for example, let me show you an example. So look at these molecules. The one on the left here is 1, 2, 3, 4, 5. It's a pentene. This is a 2-pentene derivative. So this is 3-methyl-2-pentene. And the molecule on the right, instead of a methyl group, it's a chloro group. So this is 3-chloro-2-pentene. And what I hope you'll recognize is that each of these molecules have a diastereomer. So if we were to switch, in this case, the methyl group and the ethyl group, that would be a diastereomer. If we switched the chloro and the ethyl group, that would be a diastereomer of this molecule. So these two molecules are diastereomers. These two molecules are diastereomers. The two molecules on the left are both 3-methyl-2-pentene. The two molecules on the right are both 3-chloro-2-pentene. To name these, we don't use cis and trans. We use either the letter E or the letter Z. The letter E stands for the German word entgegen, which means opposite. Or we use the letter Z, which is for the German word zusammen, which means same. So to determine whether an alkene is E or Z, we essentially have to apply the Kohn-Ingold-Prelog rules that we learned for R and S configuration to each of the alkene carbons. So if we start with this molecule here, well, first let's look at this alkene, this vinyl carbon. It's attached to a methyl group and it's attached to a hydrogen, which is implicit. The methyl group is bigger than the hydrogen. On this side, we do the same thing. We've got an ethyl group and we've got a methyl group. Here's a carbon. This is attached to a carbon and 2 hydrogen. This carbon is attached to 3 hydrogens. So in this case, the ethyl group is the larger group. Well, the bigger groups are on the same side of the double bond, or if you don't speak German, they're on the same side of the double bond, and so therefore this molecule on the bottom here is Z. The top molecule therefore must be E. The big group, the methyl group, on the left carbon, and the big group, the ethyl group, are on opposite sides if we draw a line through the double bond. So this is the E version of that molecule. On the 3-chloro-2-pentene molecule, let's do the same thing again. Well, the carbon on the left, same difference. The methyl group is larger than the hydrogen, so it wins. In this case, however, the chlorine is larger than the carbon that's attached to this alkene. So the chlorine gets the 1, the ethyl group gets the 2. In this case, the large groups are on opposite sides of the plane through the pi bond. So this molecule is the E stereoisomer. The molecule on top here is the Z 3-chloro-2-pentene. So we'll do some more examples of this in class, but that's how you name alkenes, and that's how you do the E and Z rules to designate them. One final note. A molecule that is cis has to be Z. So if you can name a molecule an alkene molecule cis, then you can therefore say Z. So Z and E are much more rigorous. So cis 2-butene must be Z2-butene. Trans 2-butene must be E2-butene. So you can always use the EZ rules. You can sometimes use cis-trans. So hope that's been helpful. See you soon.